first thing we have to go over before we even get into this. There's 4 scenarios. There's 2 scenarios for sine graphs, positive sine graphs and negative sine graphs. And there's 2 scenarios for cosine graphs, positive cosine graphs and negative cosine graphs. So I'm going to give you a sketch of each of these 4 scenarios up top. Positive sine graphs have this cycle. Negative sine graphs, how would you describe the difference between those? Flipped, really, right? The positive sine graph goes up first and then down, and the negative sine graph goes down first and then up. It's flipped, exactly, because there's a negative out in front. Perfect, right? Vertical flip. A positive cosine has a different look. A negative cosine is, again, a flipped version of that. So when we write our functions, the first thing we're going to figure out is, are we dealing with a sine or a cosine? And then are we dealing with a positive or a negative? How would you describe the difference? How do you note the difference between a sine and a cosine? What's the difference between these? Obviously, these then continue, right? In all cases. This cycle will continue. Nate? Okay, good. Anything else, Nathan? How so? Be more specific. Correct. If you're grabbing a sine curve, that's exactly it. Sine curves start and end on the midline. So they start kind of in the middle. They go up to a maximum, come back down to the midline, and then go below the midline to their minimum and come back up. So they start and end on the midline. Versus cosine curves start at a maximum. Their midline would be somewhere in here. They go down and cross their midline on their way to the minimum, and then they end at the maximum. That's a positive. Positive cosines go max to max, and negative cosines go minimum to minimum, where the midline would kind of go through the middle there. Yes? Every graph has every section, every period, and I've only drawn one period of each of these, solid, with a solid line anyway, has 5 critical points. With the sine curve, we've got 3 critical points on the midline, and then you've got 1 max and 1 min. With a cosine curve, you only have 2 intersections with the midline within each cycle, and then you've got 2 maximums and a minimum. But they all have 5 critical points. Your criticals would be anything max, mins, or on the midline. All right, so here's what you have to memorize. And this will be added to your flashcards list. The general structure for a sine or cosine graph. Okay? So we've got an A, B, C, and D that we have to decide on. A is your amplitude, or it comes from your amplitude, right? It's going to the plus or minus part is going to depend on whether you've identified it as a positive sign or a negative sign, or a positive cosine or a negative cosine. So you kind of got to know what these 4 intro graphs look like, and then your A is going to come from the amplitude. Your B is going to come from the period, which I'll get to in a second. Your C is going to come from your horizontal shift, right? And D is going to come from your midline. So here's what essentially happens. If we're talking about transformations, this gets shifted right C units. B is going to be a horizontal stretch or compression. if I take a sine curve, look up in the top left, if I stretch it out horizontally, what does that affect? Does that affect the midline if I take it and I stretch it horizontally? No. Doesn't affect the midline. It affects the period, right? If I stretch it horizontally, it's going to take longer for that full cycle to complete, so your period would have increased. If I compress it horizontally, it's going to make my period smaller. Yes? So B is going to be affected by your period. And there's a formula that we have to use often. Your period equals 2 pi over B. We're going to use that a ton. The A is a vertical stretch or compression. And can you see if I stretch my graph vertically up or compress it vertically down, do you see how that affects the amplitude? And the D is a vertical shift. Can you see how if I take a graph and I shift it up, how that affects my midline? D is really your midline. Because if you shifted your parent graph up 7 units, your midline moved up 7 units with it. Okay, so when we look at a graph, and we'll do this one, for the most part, if it's possible, it won't always be possible, but if it's possible, we're always going to assume our cycle starts right on the y-axis. And we will get to it, I think maybe 1 or 2 cases where it doesn't do that, but for the most part, it will. And then we want to kind of outline what one full cycle is. My cycle ends there, correct? Okay. So just like we spent time doing when we first looked at periodic graphs, we need to know what the midline is. We need to know what the amplitude is. We need to know what the period is. Those 3 things are going to be critical, okay? So starting with the midline, what is the midline? 0, right there, because the max is 3 and the minimum is -3. Halfway between those, or the average between +3 and -3, is 0. What is the amplitude? Three. It goes 3 above the midline to a maximum and 3 below a midline to the minimum. And what is the period? 4 pi, right? Takes 4 pi until we complete that cycle. So if I'm just looking at that one cycle, and I'm covering up the rest of it up here, is this a sine or a cosine curve? Cosine. Is it positive or negative? Positive. So the first thing I'm going to do is I'm going to write this A cosine B x minus C plus D, because I know I'm dealing with a cosine curve. And then I just need to plug in the appropriate values for A, B, C, and D. I already know A, because what's my amplitude? 3, right? So that's y equals 3. And we said it was a positive cosine, so we're going to keep that a positive 3. Cosine. B is the one that takes a little side work, because we know our period. What did you guys tell me the period was? 4 pi. So 4 pi equals 2 pi over B. And I have to solve for B. That's the only thing I have to really solve for. The A is the amplitude, we'll get that. The C is whether or not we shifted right or shifted left at all, which we did not here. And the D is whether we shifted up or down here. So we only really have to solve for B. So we put this over 1 and we just cross multiply. We get 4 pi B equals 2 pi. And how do I get B all by itself? I'm getting b all by itself, so I need to divide away the 4 pi. Did you say divide by 2 pi? You meant 4 pi. Divide both sides by 4 pi, and so b equals, and guess what? Those pi's are going to cancel, and 2/4 simplifies to 1/2. So back up to our formula, the b is 1/2. This horizontal shift, did this cosine curve get shifted off the y-axis at all? No, it's starting, my cycle is starting on the y-axis. So it didn't get shifted right or left at all, so that's going to be 0. By the way, that horizontal shift, whether or not there is one, and I'll be honest, most of the time there has not been one, just as if history is going to repeat itself. But this is called the phase shift. That's a shift vocabulary word that's specific to trig. They'll say, what's the phase shift? Not necessarily how much has it been shifted left or right. They'll say, what's the phase shift? And so we had none here because it wasn't shifted off the y-axis at all. And then what's our midline? Because D is just our midline. 0, right? This graph didn't get shifted up or down, so plus 0. And then when some of these are 0, we will simplify it. Y equals 3 cosine of 1/2 x. And then you can just really leave it like that. Because this x minus 0 didn't do anything, so it's just 1/2 x. If sometimes we might have to distribute that 1/2, but not here because the 0 is negligible. And then there was no plus 0 at the end of something, doesn't really do much. And that's the graph of that. Okay? So I do want to show you on your calculator how to check your answers. You just watch me here. And then, I don't want to hit the white button because it'll go off. Okay. First of all, anytime we're writing equations of graphs, I have never seen it in degrees. So as far as mode is concerned, be in radians. So right now my calculator is in degrees. Be in radians. If you are graphing a trig function, be in radians. Okay? Unless there's a degree symbol somewhere, which I've honestly never seen. Be in radians. So when I go to y equals, I'm going to type in 3 cosine of 1/2 x. And then when you set your window, just so I can see if this is accurate, I'm going to go from negative 2 pi to 6 pi. So if I go to my window, your zoom 6 and your negative 10s to 10s in trig don't really make sense. So look at the window of the graph that we tried to do, negative 2 pi, and you can plug that in verbatim, negative 2 pi using the pi button. When I scroll off of that, it's going to change it to a decimal. That's fine. And then we're going to go up to 6 pi. And then our y window goes as low as negative 3 to as high as 3. So I'll go negative 4 to 4 just so I see the whole thing. And then I'll see, is the equation I wrote matching the graph almost just like a checking mechanism? Are you happy with that? Any differences you notice? I think it's pretty good, right? I think maybe the only difference is this arrow, they didn't really take it all the way to 6 pi because 6 pi would have been there. They didn't really take it all. They just put an arrow on the end to show that the cycle is going to continue. But if it did, that would have been the next minimum before it turned around. Does that make sense? Okay. Any questions? We're not going to do all the rest of these on the front side, but if I just look at that first section, my cycle starting at 0, would you call this a sine or a cosine curve? Sine, positive or negative? Positive sine. Then we would go through and do the rest. We'll do more on the back, don't worry. How about in 3, without me kind of doing anything, take a minute to think about what you would call this. I'm looking for a positive sine, positive cosine, or negative cosine? negative sign. So it starts here, and it goes down first, up, and then back down. Perfect. That's a negative sign. And how about the last one? Negative cosine. Starting at a negative, or starting at a minimum rather, and then there it is. So if we don't have to do a phase shift, we're just going to call it what it is so that we're all on the same page, okay? All right, let's look at some more examples. Here's a different one, okay? So can I start my cycle right on the y-axis? Does that fit one of our 4 categories? Positive sign, negative sign, positive cosine, or negative cosine? Does it? It does, yep. It's a what? Negative cosine. So the first thing I'm going to do is I'm going to do y equals negative a cosine of b x minus c plus d. I'm going to get my structure right there on the paper. Okay? What's the amplitude? And maybe it would make sense. Well, raise your hand if you think you know the amplitude. Shouldn't be too difficult. What do you think? Negative. Let's assume we're counting by ones. I know it's not scaled. 1, 2, 3, 4, 5, 6. Okay? He thinks the amplitude is. He's saying negative 2. Amplitude is always positive. So we're going to put in 2. He's correct. The amplitude is 2. The negative there is reflecting the negative cosine x. So if ever someone says, what's the amplitude? Always give a positive number. Okay? It's really, the amplitude is actually equal to the absolute value of a. So it's going to look like our a value is negative 2. And he's correct on that. I'll show you how he got that in a second. Because really the first thing you should do is place the midline. That's really the first thing you should do. What's the middle between the max and the min? So if this is at 1 and this is at 5, this one's a pretty easy one to eyeball. It's right here, right? And they tell you it's at 3. Does that make sense? So if the midline is 3, what variable do we know? A, B, C, or D? Which one is the midline? Where did this graph get shifted? D, right. It got shifted up 3 units. Here's 0, here's 3. So the midline is normally at 0 on the parent graph, but this got shifted up 3 units. So the midline gives you your D. B is the one that takes some legwork. So period equals, I'll do it on the side, 2 pi over B. What is the period of this? When you're looking at a graph, you can tell the period. Mason's saying 16. Does anybody disagree? Correct. The period starts at 0, and that first rotation is ending at 16. So the period is 16. So if I go to my period equals 2 pi over b formula, which you absolutely have to memorize, the period is 16, and I'm solving for b. Let me ask you guys. What is the period normally on a parent graph? What'd you say? 2 pi. Okay, the period is normally 2 pi. That's one full circle. So the reason we divide it by b is because if b has a value, that means it's been stretched or compressed. Was this one stretched or compressed? 2 pi is like 6.28. So normally the cycle would have ended by here. So it got stretched. Okay? So we're going to go and solve for b. Cross multiply, we get 16b equals 2 pi. Divide both sides by 16, and b equals 2 pi over 16. What does that reduce to? Pi over 8. Very good. So then we're going to do our cosine bracket, keep our pi over 8 out in front of the set of parentheses. Did we have a phase shift here? Did this cycle get shifted to the right or the left off of the y-axis at all? No, so that's x minus 0, and we're done. We just would want to clean up this x minus 0. So negative 2 cosine of pi over 8x, and then pi over 8 times 0 is ignorable, and then the plus 3 at the end. So if you think about the transformations that you did like for homework the other day, this is technically 3.14 divided by 8, so that's less than 1. So there's your horizontal stretch, followed by a vertical stretch of 2, followed by a flip upside down, and then shifted up 3 is what happened in that order. Okay? Look at 6. What do you notice about the graph of 6? The period's not perfect. It's not complete. So do you think this is going to turn around right here? Does the way it curves indicate that it's going to kind of turn around and go up right here? Or not yet? Not yet. This is kind of opening downward, and then it kind of is going to do its shift here, right? What will this point be? If this is pi, what will this be? 2 pi. And then it's going to come back around, and what's that point going to be? 3 pi. And then it's going to come up here, and when is it going to finish its cycle? 4 pi. So the period, which equals 2 pi over b, we've just decided that the period is 4 pi. So we're going to solve for b and get that out of the way, and then we'll worry about a, c, and d. So if you put this over 1 and cross multiply, we get 4 pi b equals 2 pi. We have to get b all by itself, so we divide both sides by 4 pi. And b equals what? 1/2. So that's out of the way. Is it a sine or cosine graph? Cosine, positive or negative. So I'm just going to get that out of the way, get my structure up here. What's my amplitude? What do you think, Cameron? What do you think my amplitude is? 2, right, because the midline is right here at 0. Does everybody agree with that? The midline's at 0. The amplitude is 2. So y equals 2 cosine. I already figured out b is 1/2. What's my phase shift? 0. Doesn't shift it off at all. Plus, what's my midline? What'd you say? 0. Yep. So when I simplify this, it's just 2 cosine of 1/2 x. Now, I want to do, we're going to hold off on 7. I'm going to show you something that is you have to know, and I'm going to do this one again. I'm going to write a totally different equation that's going to give me the exact same graph. And I'm going to do it by starting my cycle here at pi. So if my cycle is doing this, what did I change by readdressing where my cycle starts and ends? This wouldn't be what you naturally do, but it's an important thing that you need to see. So what did I just do? What kind of graph is this cycle? A negative sign. So I have y equals negative a sine of b x minus c plus d. What's my amplitude? Did that change? Well, let's start with the midline. Is my midline still at 0? Yes. It's going up 2 from that and down 2 from that. So my amplitude did not change. It's a negative a value, negative 2, But that's because I'm looking at this now as a negative sine curve as opposed to the positive cosine that I initially had. How about my period? Did my period change? If my cycle's starting at 1 pi and ending now at 5 pi, isn't the period still 4 pi? Okay, so if the period's still 4 pi, the b is still going to be 1/2. But what I did here by changing the starting point of my cycle is there is a phase shift now, isn't there? The cycle is not starting on the y-axis. This has been shifted pi units to the right. Do you buy that? So this shift here would be x minus pi because it's shifted pi units to the right. And my midline is still plus 0. So the equation that is totally different but is the same graph is this. There's what we did, and that's the one that I would assume you all would do. That's a cosine, but I wanted to show you one with a phase shift, number 1. So now you see how that kind of works because this was shifted right pi units. But they're totally different. Watch what happens if I graph them. I have 2 cosine of 1/2 x, and then I have negative 2 sine of 1/2. I want that. X minus pi. And my window, I'll go from 0 to 5 pi. And my negative 4 to 4 is fine. So it's going to graph this one first, and then this one. Okay, so there's your first one. And then you see it's still working. You can see that little thing, but it's tracing the same graph over itself. So the same graph can be given by 2 different functions. I always start with on the y-axis and avoid a phase shift, but sometimes you have to do a phase shift. You'll see that one example of that on your homework. Couple things I need you to change when I hand you your homework. The first is in the directions. We need to change those to the format that we're using, which is slightly different than that. It's on the front of your notes, so you can just cross those out and do the one that's got the b with the parentheses and the x minus c. How about Alg2? I had that written down. So underneath this on your homework, I want you to change it to what we used all day today. The b with the parentheses x minus c plus d. For both the sine and cosine.